go. Diving in. We're on 3A.2 sine, cosine, and tangent. This is part A. Okay. We are now on Mrs. Jones' favorite part of pre-cal. Okay. I know. So, what do engineers, artists, airline pilots, and golfers have in common? They all work with angles. Angles is a critical part to all of their jobs and professions. Okay. We can estimate angles sometimes, like with a golf shot or if you play billiards. However, do you want people estimating angles when they're flying a plane and landing? Do you want people estimating angles when they're building your home? Like, that looks about good. The stairs shouldn't fall. No, you don't. You want to be as precise as possible. And how are they precise as possible? Well, due to engineers and programming, that is through trigonometry. Okay, that's how it becomes. So we're going to review some vocabulary about our about trigonometry and important words that you'll be hearing me saying. So standard position. An angle's vertex is at the origin, so it's centered at the origin, and it rotates counterclockwise. So this would be standard position of an angle. Okay, so this is an angle in standard position. All right. Your initial side is a side that doesn't move. Your initial side is on the positive x-axis. Okay, so the positive x-axis is the initial side of your angle. Your terminal side is the part of the angle that is moving, that is rotating. Yes, initial and terminal. Okay. So coterminal. Coterminal angles are two angles in standard position that have the same terminal side. Okay. So when you're talking about coterminal angles, it's how many times you rotate it around to get back to that terminal side. Does that make sense? So right now, this angle is roughly at, let's say, 150, right? It's not at 150, but we're just estimating. If I made a rotation, that's now 360 plus 150. Does that make sense? And I make another rotation, that's now 360 plus. That's what it means by coterminal, okay? When you have coterminal, that means that you are rotating, which means you're plus or minusing 360 degrees each time because you're rotating. We'll dive a little deeper into coterminal, but hopefully that overall makes sense. Yes? Okay, your terminal side isn't moving, just you rotating. Okay, it's like taking laps in NASCAR, right? They're lapping. Okay, what'd you say? We are learning the unit circle. All right, the unit circle. Here's our baby start into the unit circle. So our unit circle is broken to 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. It's called a unit circle because from the center to the outside of the circle is only 1 unit. So this is at 1, 0. From the center to the outside is 1 unit. This is 0, 1. From the center to the outside is 1 unit. So this is negative 1, 0. From the center to the outside is 1 unit. So this is 0, negative 1. And that is our feed into our unit circle. Okay, so continue on. Now, positive and negative angles. A positive or negative angle measure tells you the direction of your rotation. Okay, so when you are a positive angle, you are rotating counterclockwise. Okay, so positive angles are going to rotate through our cycles in order. So they'll go 1, 2, 3, 4 through the quadrants, right? If you are a negative angle, negative angles are going to rotate clockwise, and they're going to go through our coordinates and not coordinates, our 4, 3, 2, 1. It's going to go around. Okay. So quadrants. So when we talk about it's quadrant 1, then 2, then 3, then 4. When you're going clockwise, it's going to be the opposite. 4, 3, 2, and then 1. Okay. So if I was to sketch a negative angle whose terminal side lies in quadrant 3, so here is my initial side. Your initial side is always on the positive x-axis. And then you're going to rotate from 4 to 3. So I can draw it anywhere in here, and this would be a negative angle. It said sketch, you can draw any. There's no measure. Yeah, I just drew. I'm in quadrant 3, right? So my initial stayed and my terminal side ended in quadrant number 3, correct? This is a negative angle because I rotated countermeant clockwise. I went 4, 3, 2, 1. Okay. This right here, we don't know the angle measurement, right? So when we talk about an unknown angle, we call that theta. So instead of using x, we call it theta. So when you have theta, that's an unknown angle. Does that make sense? So this is a negative theta. An unknown angle measurement is just, we know it's negative because I went clockwise. Yes.
That's a Q3 or
Yes, Q3 for quadrant 3.
oh, I thought it was a theta.
No, this is the Q. I said Q3 because we're in quadrant 3. This is theta. My theta doesn't look as pretty as the actual Greek letter. You can look it up and call it a day. You're a better artist than me. But we're going to roll with the theta that I've been drawing for, I have been drawing this since I was 7. So while y'all are being funny, ha ha ha. All right. So sine, cosine, and tangent. You should have left geometry with the understanding of sine, cosine, and tangent from a right triangle. Yes, no, maybe so. Yes, you should have left from geometry understanding sine, cosine, and tangent using a right triangle. So we have our right triangle here, and we've drawn it into our unit circle. So we've drawn it on a coordinate plane, right? However, we're going to talk about what it means when you are, well, we're going to relate what you learn in geometry to what it means in terms of trigonometry, okay? So in geometry, you guys learn SOHCAHTOA, right? So, saw, whatever. I SOHCAHTOA, SOHCAHTOA, you know what I mean? I don't say it that much anymore because we're big kids now. And so either way in geometry, you learn that, right? Sine theta equals opposite leg over hypotenuse. Cosine theta equals adjacent leg over hypotenuse. And tan theta equals opposite leg over adjacent. When you write it out, it just helps you remember who is what. And so sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Geometry 101. Yes? Okay, now we're going to take what you learn in geometry and tie it into trigonometry. So when you are looking at the sine of theta, sine of an unknown angle, yes, if it's a right triangle, it's opposite over hypotenuse. But in terms of a unit circle, your opposite represents your leg, your vertical leg, which is your y. So it becomes y over your hypotenuse represents your radius. So it becomes y over r. Do we see that? Okay, your cosine is normally your adjacent leg over your hypotenuse. In terms of a coordinate plane, it's going to be your adjacent leg represents your horizontal leg, which is your x, and your hypotenuse is still your radius, which is r. So this equals x over r. Okay, your tan theta is your opposite over your adjacent. Your opposite leg is your vertical, which is your y. Your adjacent leg is your horizontal, which is your x. So when we're defining them, it comes down to be y over r, x over r, y over x. That is how we identify sine theta, cosine theta, and tan theta from a coordinate pair. Okay. The relationship here is you also learn how to find unknown parts, missing pieces of a right triangle, right? Does anyone remember what it's called to find the missing piece of a right triangle? Perfect. Pythagorean theorem. Okay, Pythagorean theorem, as you learned, it was a squared plus b squared equals c squared, where a and b were your legs of your triangle and c was your hypotenuse, correct? Now, a and b are now your x and your y, and your hypotenuse is your radius. So do you see how we took what we learned in geometry and transferred it to trigonometry?
Yeah.
That's all we had to write there. We're written or wrote in the box. Okay, how do we feel? We're correlating. Okay. So it's all written out for you if you didn't get it down. It's all prettily written for you. All right, so right triangle form. So we took what we knew. So now, in conclusion, our sine theta is going to be y over r. Cosine theta is going to be x over r. And tan theta is y over x, which means that tan theta equals our sine theta divided by our cosine theta. Okay? Yes? Do we see that? All right. So we've now made these connections. Now we're going to keep going. Yes? All right. So if you have this figure, this circle here, and you wanted to find the coordinate points of M, T, and H in terms of X and Y, meaning identifying where they're positive and negative at, right? What would that be? So if A is XY, what would that make M? Mm-mm. If A is XY and they all have the same theta, what is M? There you go. M is negative XY. What is T? Negative X and negative Y. What is H? Positive X, negative Y. Okay, that's because in each quadrant, there's rules to follow for your X's and Y's, correct? In quadrant 1, X and Y are both positive, correct? In quadrant 2, X is negative and Y is positive. In quadrant 3, both are negative. I didn't mean to write 3, I meant to write an X. You see nothing. X and Y are negative, and in quadrant 4, X is positive, Y is negative. Okay, this is important because when we talk about X's and Y's, we're going to start talking about X's and Y's being sine and cosine. Does that make sense? Okay, so when we talk about X's and Y's, our X is going to represent our cosine, and our Y is going to represent our sine. So by understanding where X's and Y's are positive and negative, that means we understand where cosine and sine are going to be positive and negative. Does that make sense? So in quadrant 1, both are positive. In quadrant 2, only sine is positive. In quadrant 3, both are negative. In quadrant 4, only cosine is positive. Yes? All right. I'm going to sound repetitive, but just accept this, okay? Because the more you hear it, the better it's going to stick, okay? So when we talk about this, the sine of an angle whose terminal ray intersects the circle at point H, what is the sine going to be? What is sine going to be? Sine is not X. It's going to be negative because sine is your Y. So if it's in point H, then sine is negative. And it's negative because point H is in what quadrant? It says sine. It all kind of came together. Sorry? Sine? I was underlining that sine is Y. Okay? The cosine of an angle whose terminal ray intersects the circle at point P. So cosine means X. Yeah, point M, sorry. Point M is now where? Quadrant. So cosine is negative. And quadrant 2. Okay, now tangent is tricky. Tangent is, what's the relationship between tangent and X and Y? Tangent is Y over X. So tangent is a combination. It's Y over X. I meant to do a squiggly line. Ma'am, I knew what I was doing. All right. So point T is in quadrant 3. Do we see that? In quadrant 3, what is the relationship between our X's and Y's? They're both what? They're both negative. So if tangent is y over x, and we have a negative sine and a negative cosine, what does that make tangent? Positive. Tangent is positive. So tangent is positive in quadrant 3. Why?
No, go back.
All right.
Whoa.
Maybe just a little less talking and more writing. I need you to further elaborate what I need to explain so I don't repeat myself and then say the same thing over and over.
So what shows that negative on the side?
Is your values? So you're just like if you were to plot points, what are the signs of the points? So in quadrant 1, x's and y's are positive. In quadrant 2, negative x's, positive y's. Quadrant 3, negative x's and negative y's. Quadrant 4, positive x's, negative y's. And based on what we've written already, we know that x equals cosine and y equals sine. And that's all you're doing. So relating what they are. All right, so here we have the figure at right shows a circle with a radius of 5 centered at the origin with an angle measure of theta, because the angle measure is irrelevant, right? In standard position. The terminal ray of the angle intersects the circle at point Q. Find the following of everything. So first off here, we know that if it was in quadrant 1, it would be positive 4 and positive 3. However, my terminal side ends in quadrant 2. So what is the ordered pair in quadrant 2? Negative 4 and positive 3. Agree? Yes. Okay. And then also tells me that the radius, so the distance, is 5. Your radius is always positive. Your radius is always positive. So I'm going to identify everything that I know. I know that the point, my terminal point is Q. Q is at negative 4, 3, which means that my X is negative 4 and my Y is 3. It also told me that my radius equals 5. Are you with me? Okay, so going back to what we wrote about the relationship between our coordinate plane and sine, cosine, and theta. Sine is your y divided by your r. Do I have that information? So it would be what? 3 over 5. So sine theta of this angle is 3 over 5. Okay, cosine is x divided by r. And what is my x value of this coordinate? And my radius is 5. Tangent is y over x. What is my y value of this coordinate? And that is the sine, cosine, and tangent given the ordered pair in the radius. You can't simplify, you can do nothing. That's it.
Is that ordered pair what does that represent quarter 2?
Quadrant 2, because it says your terminal side. So this is a T, sorry. My terminal side ends in quadrant 2. Okay, this is the baseline of being able to evaluate sine, cosine, and tangent. How do we feel? All right.
Right.
All right. So here it says the figure above shows a circle centered at the origin with an angle of measure beta. Beta is just another way of representing an unknown angle. Don't freak out. Beta just means theta, just like you have X's and Y's and G's and F's. Okay. The terminal ray of the angle intersects the circle at point P. Which of the following is true about the sine of beta? Okay. So if I'm looking for the sine of beta, what has to be true about it? Yes, but in terms of this, what do we know? Sine is y over r, okay? And what's our r? So we know r equals 4, and we know that sine equals y over r. So what must be true? Good job, Randy. And she's a genius. Okay? The reason why it's negative y over 4 is because it tells us that from the center to this point, our radius is going to be 4. Okay? That's our horizontal. And then since we're in quadrant 4, we know that it has to be a negative y. And that's it, y over r. We don't know the value of y, so therefore we just leave it as y. But we do know our radius.
Is B that center point?
Beta?
Beta.
Beta is an angle. It's just saying this is your angle. All right. So let's talk about it again. So we have let alpha, again, it can be any number. It's going to be Greek letters all the time. Alpha be an angle in standard position whose terminal ray coincides with the line y equals negative 2x in quadrant 2. The scenario label the triangle and find the following values. Okay. This takes you back to algebra 1. Y equals negative 2x. That is just a line that goes through the origin, correct? With a slope of negative 2. Agree? So it's a line. It's going to go through the origin. And we're only focusing on, we're going to draw it out, but I'm going to just make sure we understand that it's just a slope of negative 2. So we go up 1, 2, and over 1. So the line is doing this. And it's going here. Yep, that was not straight. Couldn't even pretend. No, PowerPoint has yet to install that.
Oh, that looks pretty good, Michelle.
This is me, all me. Yeah. All right, so here's where it is. So when we're analyzing this, it says that we're only using, so we have our initial side is here, and this piece is our terminal side. Okay, so once we're here, we're going to figure out its values. To find its values, we're going to we're going to turn it into a right triangle. I can. Makes you feel better. Okay, so it turns to a right triangle. Now I'm going to identify a point here. So what is my horizontal displacement? 1. I don't know why I made it so small. I could have went big. I don't know. Yes, it would be a negative 1. And what is my vertical displacement? 2. My vertical displacement is 2. Oh no, I don't know my hypotenuse. How do you find the hypotenuse of a right triangle? Oh my gosh. But instead of a squared, we're using x squared plus y squared equals r squared. Huh? Nope. -1 squared. Okay, so our x value, which is our horizontal displacement, is -1. Our y, which is our vertical displacement, is 2. We're getting there, Hudson. I got to write it out. Okay, so we have 1 plus 4 equals r squared. That gives us 5 equals r squared. So therefore, r equals square root of 5. So now we have our r. We know our x is -1 and our y is 2. Can I identify the sine, the cosine, and tangent now?
Let's do it by ourselves.
You are going to do it by yourself. 30 seconds. Go. Huh? Your alpha? It's alpha. No, Greek letters have capital and lowercase. Fun fact. Don't think of it opposite and hypotenuse anymore. Think it of x's and y's. Because we're big kids now in trigonometry. No, fractions are our friends. All right, so for sine theta, no, please do not. Fractions are our friends. So y over r. So we should have 2 over the square root of 5. Okay. The only thing here is that they will not accept this as a mathematically correct answer. Okay. You cannot have a radical in your denominator as your final solution. So we don't do that. It's called radical. We gotta rationalize the denominator, which means we're gonna multiply the numerator and denominator by that radical. Because you're not allowed to have a radical in the denominator. I'm sorry. A radical is a root, square root,
You
radical.
can avoid all this by finding the decimal.
That is what we want. No more having you cannot have a square root or radical in the denominator. So we rationalized our denominator.
How would that not equal the same thing?
I didn't say it didn't equal the same thing. The same thing as in English when you don't put a comma.
I never put a comment and I still passed.
See the correlation there? Okay. All right, so x over r. So your x over r is -1 over the square root of 5. Again, we're rationalizing. So we end up with negative square root of 5 over 5.
If I had to do with the one thing.
It's still the same. Casper, the friendly one, is good to go. And then last is y over x, which is just 2 divided by -1. And that gives you what? -2. Okay. All right. How do we feel about part A? Okay. Still with me?